right, let's just review from yesterday. So if I am going to have you guys graph 290 degrees on the XY axis, got a couple questions for you. Here we go. Number 17, got a question for you. Where is always one side of my angle? Nice job, JT. Thank you. Going this way. And the other side's going to be whatever quadrant 290 is in. So what quadrant is 290 going to be in? Here you go. 12. What quadrant? Quadrant 4. Yep. Because remember, 270 is right here, followed by 360. So it's got to be in between there. One more thing I am missing. 10. What am I missing from my angle? Which way? Clockwise or counterclockwise? Because any positive angle should be going counterclockwise. Correct. Nice job, guys. Second part of this is, where's the reference angle? The reference angle is always formed by the terminal side and the x-axis. Do we see the reference angle? All right. And also, another thing to keep in mind, it's always positive and has to be between what? 0 and 90. Okay, got to be between 0 and 90. So here's my reference angle. Now the question is, and this is where I get nervous, is do you know how many degrees in that reference angle? I don't know. What was this? Anybody know that Greek symbol? Is it alpha? Did it say on top? I don't. It's alpha? Okay. So how do you find that reference angle when I put the subscript? 1, how we doing? Doing great. 14? Yep, 360 minus 290. And what do we end up with there, Mike? How much? 70. Quick check, between 0 and 90? Yes, it is. So there's my reference angle. Everybody good? And again, I can't stress this enough. When finding a reference angle, never use 90 or 270 because those are on the y-axis. Y-axis. All right, one more. Let me go in the negative direction now. Negative 242. JT told us in the last one, no matter what the angle is, initial side's always to the right of the x-axis. Where would negative 242 land? In what quadrant? 9, what quadrant? Second quadrant. How do we know that? Well, that's negative 180. Here's negative 270 going clockwise. Let's see, where's that closer to? Oh, you're going to answer? Sorry. I'm trying to think myself. 242. It's about 30, so I think it's closer to 270 myself. Yeah? All right. What's it missing? What's my diagram missing right now? 12, what's it missing? Which way this time? No, that's not going to fly with me. There you go, clockwise. Okay, everybody good? Do you see the reference angle? I'm not asking you what it is yet. Do we see it right here? Okay. I know people struggle with the negative degrees and trying to figure out what the reference angle is. Remember, your reference angle is never negative. It should always be positive. So let's talk together here. I won't single anybody out. Let's talk about this together, how I can find that degree measure. Now, hey, I know it says it's negative 242, but it's still 242 degrees. Positive or negative, it's still 242. And this is still what? Still about 180. All right, going from here to here is still 180. So what can I do going from 242 here to the 180 and seeing what's left in between? I can subtract them. 242 minus 180, 62. 62? Yeah, all right, never mind. I wasn't doubting you. I just saw something different real quick and shut my mouth. Everyone all right? So do we feel comfortable here? More practice, the better, but that's, up to you guys. We can graph an angle and we can find the reference angle. All good? Yeah. Because we're going somewhere totally different today. What? That was the angle. And then when I put an R subscript, that means it's reference angle. It's a Greek letter. Like yesterday we used this, the beta. Could just be any, I could put X there. But as long as I got the subscript of R, you're telling me that's the angle's reference angle. Okay? You all right? Yeah. Others? Anything else? Because we're going totally different direction today. Yeah. Okay. So here's what I'm going to need you to do because we have a little group activity that you're going to help me out with. All your mathematical career, and I'm talking elementary school, middle school, and 3 years of high school, you have always been told that you measure an angle in what type of units? Degrees. I hope, though, that's the only one. Degrees. That's about to change today because there's another unit you can measure it in called radians. How many times have you had to clear your calculator in your high school career? A ton, right? And the very first thing the teacher always used to say after you cleared it was, go back to your mode and put it in degree mode, right? Did you ever notice what was next to degrees? Yeah, that's another way of measuring an angle. All right, don't worry about that right now in your calculator, though, because we're not going to have to do that today. All right, what I'm going to give you guys right now, every group's going to get a piece of string, and I only have one pair of scissors, so we're going to have to just quickly share them around. What I'd like you to do right now, everyone see the radius that is drawn on the circle of your paper. I would like you to cut a string pretty exact to the length of that radius for everybody in the group. Okay, so measure it out, cut it, give it to somebody. Measure another one out, cut it, give it to somebody. Move the scissors off to another group. Okay? So that's what you're going to be doing here in the next 2 minutes, hopefully. Please make it exact, all right? Please make it exact. Hey, if you have scissors, it'd be even better. While you're waiting for the scissors, can you please get out your reference sheets? While you're waiting for the scissors, let's get out your reference sheets. And we do need it pretty exact for this to work. All right, here's what I need you to do right now. I need you to place that one end of the string on the end of the radius that I drew in for you. And what I'd like you to do is stretch that string along the arc right now and mark where it ends. Okay, mark where it ends right now. So here you go. Yep, that's fine. That's why I'm going to demonstrate it. So I'd like you to put it at the end of the radius right here. Stretch it along the arc and make a mark where it ends for me right now. Okay, see what I mean? Okay, so put your string along the arc and make a mark where it ends. Everyone can handle that. We've handled that all right? Okay, where's your radius length string?
We needed a length that was
Yeah, that's what I asked for. One that was this length.
Okay.
Okay, so I'll give you the scissors back.
Yeah.
Okay, that's what I needed right there.
All right, I'm sorry.
I asked her to cut it.
Everybody have that, so we can move on. Everybody have that. Yes, no? Okay, what I'd like you to do then is draw another radius to that point you just made on your circle. So you should have an angle inside the circle right now. Actually draw it with your pencil. Hey, here you go. Here was mine, so I'm just going to draw another radius to that point. Doesn't have to, you can freehand it. That's fine. What you guys just created, this angle right here that you guys just made with your string, you made 1 radian. This angle measure is 1 radian. When is a radian formed? Ready? You tell me what just happened. When the radius and the arc are what? Equal to each other, the same measure. All right, that's when 1 radian is formed, when the radius length and the arc length have the same measure, which everyone agrees they do on your paper, right? Because that string, you went here and then you measured it here. Now, here's my challenge to you and your group. Take your string that's the length of your radius. How many of those can fit around the entire circle right now? How many of those can fit around the entire circle right now? Be precise for me, please. Be precise. How many of those strings can fit around the entire circle? Hold your answers just to your group. Hold your answers to your group. Don't yell anything out. How many? I'm hearing some good stuff here.
I love my dad. She's mean. Grace just has a lot of issues. Yeah, with my parents.
We almost there? Let's see if we all came up with kind of around in the same ballpark here. How many pieces of string did you fit around your circle?
5
I'm hearing 6 a lot. Did anybody get 6 and just maybe a little piece of the string there?
Yeah.
Yeah, that's where it happened there. You should have get 6 and a little more. All right. Now I let yeah, if I could talk. Yeah, laugh it up, kids, laugh it up. Laugh it up. Yep. Ha ha. All right. Anyway. All right. When you're done, let me know. All right. When you're done, we all, even the great ones, make mistakes. All right. I'll get thrown in the roaster too. I had you go all the way around. How many degrees did you go? You went 360 degrees. And how many radians fit around there?
6.4.
You're going 0.4. What if mine was 0.3? 6 and change, right? 6 and a little more. But that's not really mathematically appropriate to say 6 and a little more. All right? So we're going to be more exact and say 360 degrees is the same as 2 pi radians. Here's why I'm saying 2 pi. If you have a calculator in front of you, calculate the number value for 2 pi. Right above the caret.
Right above the carrot.
6 and change, right? Okay, so that's what 360 degrees is equivalent to in radians, is 2 pi radians, or 6 and a little more. That's what you just proved on your circle. Right? Challenge you now. What do you think 180 degrees is going to be equivalent in radians? What do you think? Just pi radians. Cut it in half, right? All right, more of a challenge. Because remember the numbers that we went by. We went 0, there was 180. What was in between those two? What was in between 0 and 180? What do you think 90 is going to be equal to? Nice job. You can write 1/2. Here's how you'll throw pi divided by 2. And what was the other value I'm missing? 2. Ooh, this one's going to be a little tougher, huh? Halfway in between these two, right? 1 pi and 2 pi. What's halfway in between 1 and 2? 1/2 pi. I'm going to write it as, hey, 3 pi over 2. 3 over 2 is 1/2. Nice job, guys. Nice job. But what if I gave you just a random one? Like, what if I gave you 210? You're going to be like, whoa, I have no idea. I can do this by 90 stuff, not too bad, but when you give me something that's not a multiple of 90, I'm stuck. No, you're not. Everyone have your reference sheet out. Okay? I'm going to skip over the next 2 questions right now to get to how to convert from degrees to radians and radians to degrees. So can you go to just the next page for me? And we'll get back to those 2 questions at the end of class. Okay. So first one I want to go to is radians to degrees. We already know a couple. Ready? 2 pi is equal to what in degrees? 360. Pi is equal to what in degrees? 180. So we know a couple of them. All right. But how do I just go from a random one now that's not one of these special ones that I know off the top of my head, like 7 pi over 6? All right. First question I always get is, well, how do you know that's radians? All right. Here's the simple answer. It's got pi in it. Okay. Usually when something has pi in it, we consider it in radians. And we want to change it to degrees. Everyone, please look at your formula sheet. Do you see where it says radians equals degrees? Everyone see that conversion? That is what I'm going to multiply by. So I'm going to take my radians, 7 pi over 6, and multiply that by, what's it convert to on the formula sheet? 180 over. Everybody see the conversion on your sheet. Radians equal degrees. So I'm going to multiply it by 180 over pi. And here's why I do that. What's on top and on the bottom that's going to simplify out? Darn right.
Yay!
But what do you do from here, though? I don't want to leave it like that. That's garbage. Multiply the numerators divided by the denominator. So 7 times 180 divided by 6. How many degrees are in 7 pi over 6 radians? 210 degrees. Quick question. So what quadrant is 7 pi over 6 in? What quadrant? 3. Why? Because you know 2 10's in the third, meaning 7 pi over 6 is in the third. All good? Okay, that one doesn't make you great. Can you make a 3b for me? And let's go 6 pi over 5. Actually, you go, yeah, 6 pi over 5. It's in radians. The conversion is what on your formula sheet? Radian, 2 degrees is 180 over pi. Get rid of the pi's. 6 times 180 divided by 5. Is that a decimal? Because I just made this up. No, nice. It's going to be 216. Okay. Degrees. Now, is there always going to be a pi to cancel out? And the answer is no. Skip down to question number 5 for me, guys. Radians do not always have to come with a pi. Okay, it just makes it more exact. Like, did we want to write 6 and change? No, we wanted to write 2 pi. So what if my angle was 5.8 radians? 5.8 radians, and I want it in degrees. Nothing changes. What do you still multiply by to go from radians to degrees? What do I multiply by? Okay, 180 over pi, but guess what's just not going to happen here? Yeah, I'm just not going to cancel the pi's out. I'm going to put it in my calculator and divide by it now. All right, so yes, it is possible that sometimes your radians won't have a pi with it, but we can still convert it to degrees. And the directions say nearest degree. Nearest degree, what are we looking at here? 1, 10. Karma. 332 degrees.
Yeah. All right.
Tell her. Yeah. Hey, did we use negative degree measures yesterday? Did we use negative degrees? So you can have negative radians too. So negative 2.5 radians would be equal to how many degrees? Negative 2.5 radians, how many degrees? Still multiply by what? 180 over pi. Still going to be negative. No pi to cancel out here. And once again, to the nearest degree. Number 1, no. Number 3.
143. Negative 143. What?
So do we see the pi's won't cancel out every time?
Yeah.
Okay, last thing I have to show you. What about going the other direction? Degrees to radians. Look on your formula sheet. New conversion, right? What are you going to multiply by now when you go from degrees to radians? Pi over 180, yep. So 120 degrees, number 4 now, 120 degrees, I'm going to multiply by pi over 180, but here's the thing, hey, here's the thing. Remember how most of our radians were written out with pi in it? So don't put it in your calculator. Leave the pi in your answer, because that'll signify its radians. But what you will have to do in your calculator is reduce what? 120 over 180 for me. And that reduces down to what? 2 over 3? So 120 degrees is the same as 2 pi over 3.
Does pi always go at the top?
Yes, it will. Great question. It will always go at the top. Yep. Or off to the side, but never in the denominator. If you guys got to go, you can go. Yes, that's fine.
Have fun, Don.
Okay.
Good luck learning a new routine. 10 minutes. What? Not helping out.
Everybody good? Questions?
I am. I'm in a better mood though. Until I go home.
All right. Let's try to put this. You guys are doing a great job, by the way. This is usually a disaster, this first day of Radians, but you're doing a great job. How's it going, Kylie? All right? Picking this up? Figuring out what to multiply by?
Well, yeah, I understand what you just went on.
Okay, so we're good? Okay, so here's what we got to do now. Which one?
Like this.
What about it? I was just trying to show you how many fit around 360 degrees.
Oh.
And it was about 6 and a little more. Well, you'll end up just knowing it like that. We're going to use it so many times. Okay? But you see where that 2 pi came from. Because 6 and a little more, which is 2 pi, fit around there. Okay? Good? All right. Here's what I want to try to do to finish up. And we're going to keep doing this because don't do the assignment this weekend. We're going to do it Monday in class. Okay? So you're welcome.
Thank you.
Okay, yeah, too late.
Is it going to be a group assignment?
It might be.
No.
All right, here's what I want to do. Everything we did yesterday in degrees, I want to do it in radians now. Remember finding a reference angle? I want to do it in radians now. Coterminal first, though. Coterminal. Anybody who was here yesterday, explain if 2 angles are coterminal, what they share. The same side, right? And if you guys look back in your notes, if I said, hey, name another angle that's coterminal with 250, what did you do to that angle? You either added or subtracted what? 360 to it. Well, we're going to do the same thing now, but not add or subtract 360. What is it in radians? What did we go over very beginning of class today? 360 is the same as 2 pi. So instead of adding and subtracting 360, When it's in radians, I'm going to add and subtract 2 pi. Okay? And we need to come up with one positive and one negative measure right now. So, going back, 5 pi over 2, all right? So you guys yesterday added 360, right? But now I'm not going to add 360. I'm just going to add 2 pi. Can you guys come up with a common denominator? And I think you guys could handle this. This is why I'm showing it this way. What? 2, right? 2. What's going to be left on top? 5 pi plus, got to multiply that by what? 2, right? So 2 times 2 pi. 4 pi. So what's another angle that's coterminal? 9 pi over 2? What? Okay. But the direction said not only do I need a positive, but I also need a negative. So what else could I do here? I'm going to have to work down here. Sorry. 5 pi over 2 minus 2 pi. And we're going to run into a problem. Let's see if you can fix it. So common denominator still 2, right? And now it's going to be 5 pi minus 4 pi. So what do I end up with here? Pi over. Problem, though. I didn't ask for 2 positive answers, did I? What did I ask for? A positive, which I have, and a negative. So thoughts what I could keep doing the pi over 2. Subtract another 2 pi. You guys are on point. What's my common denominator? Sorry, I didn't give you guys much room. 2, so it's going to be pi minus. What's this one going to become when I multiply it by 2? 4 pi. So what's the negative version here? Negative 3 pi over 2. Yep. So there's my positive 9 pi over 2. There's my negative 1. Negative 3 pi over 2. And what do I got here? All right, I got time to do. Can we skip to number 7A? Because we can do 6B in class on Monday. And actually, that one's not going to take too long. Can you sketch this angle, negative 5 pi over 6? Probably not, because it's in radians, right? But if you knew it was in degrees, you could probably sketch it. Everyone agree? Okay, so can you help me convert that to degrees so I can sketch it appropriately? What do I multiply by? Look on the formula sheet. Radians, degrees. 180 over pi. What's going to simplify? Pi's are gone, yep. What are you left with? Negative 150? What quadrant is negative 150 in so I can graph it? Quadrant 3. You guys are on fire. Here we go. Rotation arrow going where? Clockwise or counterclockwise? Do you see its reference angle? Okay. How many degrees in that reference angle? 30? 180 minus 150, right? That's a 30-degree angle. Everyone agree? But last thing here, what's the direction say? Final answer in radians. I don't want 30 degrees. I want what it is in radians. Oh! What are you multiplying that one by now? Nice, guys. Nice. So it's going to be what pi over 180? What pi here? Let's see. What's it reduced to? 30 over 180. 1 pi over 6, which reduces down to. Yep. And I'll show you a little something quick on Monday about how you don't have to do all that work. You can just look at that here. All right, enjoy. We got to wait for the announcement.